Hello everyone. In this video, we are going to perform sentiment analysis on a given text. So the data is given to us in the form of a text file, and from that data, we are supposed to change it to a data frame, apply a text normalization, and then perform sentiment analysis. So let us begin. So before we begin over here, you can see that we are supposed to predict the sentiment of a given text and predict if that text is positive, negative, or neutral in nature. So let us begin by importing our libraries. So as you can see over here, I've imported pandas. So pandas basically help us to create data structures and manipulate them. So the data is read by the help of pandas, at the same time manipulated by the help of pandas. And then our second import over here is NumPy. And NumPy is a Python library which helps us to work with arrays. And not only arrays, NumPy also has domain over algebra and matrices, and NumPy basically stands for numerical Python. And over here I have matplotlib.cm. So what matplotlib.cm does is that basically matplotlib is a plotting library, and .cm over here stands for color maps. And then over here we have matplotlib.pyplot. So matplotlib is, as I said before, is a plotting library. And let us go ahead with our next import over here, which is the matplotlib RC params. So whenever matplotlib loads, it defines a runtime configuration, and this is the matplotlib inline. And what this really does is that it will make plot outputs appear, and it will store the plots within the notebook. And over here I've imported warnings. So this will basically ignore all such warnings which we get. And this is the other imports over here. Import Haryo over here. RE here stands for regular expressions. So regular expressions are nothing but they are a special sequence of characters that help us find or match with other strings or other set of strings. And then over here we have NLTK. So NLTK basically stands for Natural Language Toolkit, and it is our platform which will be used for building programs for text analysis. Okay, and then we have string over here. The string module contains a number of functions to process standard Python strings over here. And then we have NLP utils. So as I said before, NLP stands for Natural Language Processing, and NLP utils over here, it basically offers a set of APIs to work on strings such as names, sentence, paragraphs, and tokens, which are actually represented in an array of string or words. And what counter does is that Python counter is actually a subclass of dictionary class, and it basically keeps track of the frequency of each element in a container. So counter will help us to keep a count about how many times a particular word is repeating. And then we have imported stop words, and stop words are nothing but they are words which do not add any meaning to a sentence. Like even if we remove these words, they do not have any impact over the meaning of a sentence. Such words are called as stop words. And words included in stop words are like is, the, if, a, and so on. And then we have imported a WordNet lematizer. So basically when it comes to WordNet is nothing but it's a large, freely and publicly available lexical database for the English language. And when it comes to lemmatization, it offers lemmatization capabilities, as well as it is one of the earliest, and it is the most commonly used lemmatizers currently. And over here we have imported word cloud. So word cloud will help us to visualize our words. It is basically a graphical representation. It will keep the count of frequency of a particular word and give greater prominence to words that appear more frequently in a given text. So it will help us display most repeated words in a graphical way, and we'll see how this visualization looks like. And over here we have tokenization. I've imported sentence tokenization as well as word tokenization. So when it comes to tokenization, tokenization is nothing but it is a process of splitting a string or a text into a list of tokens. So they can be done in two forms. One is word tokenize and the other is sentence tokenization. And after that, we have imported TF-IDF vectorizer over here. So what TF-IDF vectorizer does is that it will transform text to feature vectors, which will be used to which will be used as used as an input to estimator. So after that, I've imported port stemmer, Lancaster stemmer, and snowball stemmer. So stemming is nothing but it is a process of reducing inflection in words to the root forms. So words like stemming will be transformed to the root word that is stem, and that is what all these stemmers do. We can use any one of them. And then I've imported label encoder. So what label encoder does is that if we have a column which has a categorical variable in them, label encoder will encode them into numeric form, and that is done with the help of label encoder. So basically all the categorical features will be converted into numeric ones. And then I've imported train test split over here. So with the help of train test split, we will convert our data into train and test parts. And then I've used logistic regression over here. So logistic regression is our machine learning model, and this machine learning model will be evaluated with the help of our metric, which is our accuracy score over here. And then the data is given to us in a text file. So we read it with the help of this code with open text analytics.txt. So this is the text file, and once we read it, this is how the text looks like. It has around 999 lines of text. And then we begin with text normalization first. And what text normalization really means is that it is the process of transforming a text into a canonical standard form. So it will convert all the text into a standard form. For example, the word good and good can be transformed to the word good, its canonical form. Another example is mapping of near identical words such as stop words. So stop words are something we'll have to remove in our text. And then what we do over here is we split the text wherever there's a new line with the help of this code. So text.split/n will separate the text wherever a new line is present. And after that, we separate the text wherever there's a tab space. So we do it with the help of /t. So /n stands for new line and /t is a tab. So we have separated our text from with the help of /n and /t over here. And then this piece of code here, what it really does is that it unlocks only characters from A to Z and capital A to Z, excluding other characters. And then coming to tokenization. So let us see what tokenization really is. So tokenization is the process by which big quantity of text is divided into smaller parts called tokens. So we basically split our text into words, which are called as tokens. And over here we have natural language processing, which is used for building applications such as text classification and chatbots, and sentiment analysis. So we basically convert the text into smaller tokens. Over here, what we have done is that we have converted all our characters into lowercase with the help of dot lower. And what this will do is it will convert all the characters in our text into lowercase. And over here, we have tokenized them. We have tokenized the sentence with the help of sentence tokenization. So I've saved all the lower letter characters in the letters only, and I've sentence tokenized these letters only, and this is our sentence tokenized text. And then what we have done is I have removed all the alphanumeric characters. So we'll have to remove all the special characters present in our text. Once we have done the sentence tokenization, there might be a few places where there are special characters, and such characters have been removed. And over here, this function over here shows us that all numerics are represented with x over here. And if we have a decimal value, then it will be represented by triple x over here. And so we have replaced all the numeric values with these values. And then we have created another clean NDA. And what we really do over here is that we have taken all the tokenizations and we have mapped them. And this will remove all the special characters in the end, and all the alphanumeric characters and other such decimal values have been replaced now. We have replaced them with characters like XXAA, and after that is done, we remove contractions. It's not actually removing contraction, it is expanding contractions. So contractions are words like isn't, didn't. As you can see over here, these words get converted into is not, they get converted into their full form. So over here, there are converted to they are. So it is basically expanding contractions, and we do that with the help of contraction map. So we have taken the corpus NDA over here. We have saved our text before in corpus NDA, and this holds our text. So we have taken this corpus NDA and we have done the expanding contractions. And after that, we have word tokenized our corpus NDA. And again, we have, as you can see over here, dot lower changes it into lowercase. And once that is done, all the words are converted to tokens and contractions have been expanded. And at the same time, we have also converted our letters to lowercase. And this is the resulting text. And over here, we need to save this text into a data frame. So what we do is we split it by space tab. We remove the tab spaces and new lines. And in the end, we have this data. This is our resulting data, which has to be further cleaned. And we take this data and save it into a data frame. And this is how our data frame looks like. And as you can see over here in this data frame, there are a few additional columns like 1, 2, 3, 4, 5, and 6. These columns are to be dropped, and we have dropped these columns, and this is the resulting data frame. And further processing has to be done on this data. Over here, you can see that this column is called as 0. So what we did is that we have replaced the 0 with text using the rename function. We have just renamed this column from 0 to text. And this is the final data set that we are left with. Okay, and over here you can see that in this data frame there are a few rows like the 0. You can see that these are repeating twice, the 0 and 1. And in this column we also have these 999. This index is again having two texts that are repeating, so we need to drop this. So rows 0, 1 and 1000 and 1001 have been dropped. And as you can see, now we have our 1000 rows. So this is the correct data set now. And we need to remove additional characters present in this data set now. So I have used this code over here. So this code, what it really does is that wherever it finds digits, it will remove them. And commas and BR and all such special characters have been removed. And some characters have been stripped. As you can see over, we used a string.strip over here. And this way we have cleaned our text now. And then we come to the lemmatization. Part. So what really lemmatization does is that as you can see, lemmatization usually refers to doing things properly with the use of vocabulary and morphological analysis of words, normally aiming to remove inflectional endings only. So this is similar to stemming, what it really does is that it will take words and convert them to root words. Like lemmatizing will be converted to lemmatize, and other such words like cooking will be turned to cook. So this is what lemmatization or stemming will do. And I've applied our lemmatization. So we have applied lemmatization using the apply lemmatization sentence function over here. And this is the resulting text. Over here, we have converted this text as matrix. So the as matrix function, what it really does is that it would convert the given series of data frame object to NumPy array representation. And over here, we have done the sentence tokenization of this token, and we have saved it in a form of array. And over here, our next thing is to remove stop words. And as you can see, once we have removed the stop words, as I told earlier, stop words are words which do not have an impact. Even if we remove them, the meaning of the sentence still remains the same. So such words are stop words, and words included in stop words are the is of such words are called as stop words over here. And we have applied these stop words and we have removed all the stop words from our sentence. And this is the resulting sentence over here. As you can see over here, the other words have been removed, and all the stop words have been successfully removed over here. And next thing that we do over here is we do some visualization over here, and we use word cloud. So this is how a word cloud looks like. And over here we have used word cloud and we have given the parameters over here. We have taken 1,000 words are the limit over here. We have given the white background, as you can see over here. And these word cloud over here shows us all the words where all the stop words have been removed. So this is a word cloud without any stop words in them. So as you can see, the bigger the word, the higher the occurrence of this word in such sentence. So the word film repeats a lot in the entire text. So that's the reason why you can see the film as a bigger with the bigger size compared to other words. And this is how the word cloud looks like. So we can clearly see that the word film has repeated a lot, followed by movie, and movie also has been repeated a lot in the text. So we can count the number of words and the number of occurrence of such words. And over here we can see that we have used counter, and counter will show us the counts of all the words that have repeated. And as you can see over here, we have the word movie, which has repeated for 2018 times in the entire text, followed by film. So basically this image has been represented over here, and that is these are the most common words that have repeated, and the word movie has repeated for around 2081 times so far. And this list is without any stop words in them. And after this we have used a bar plot or a bar graph over here. So the stop words were removed, and this is the words. These are the top 10 words that have repeated. And as you can see over here, movie has repeated for around 2000 times over here. And this is the graph, and followed by film, and then the other word is one, followed by make, and so on. So this is the bar graph. And now let us go ahead with the sentiment analysis part. So sentiment analysis part, what we have to really do is we have used something called as weighted sentiment analysis. So this weighted sentiment analysis will help us find if a given sentence is positive, negative, or neutral in nature. So let us see what weighted sentiment is really about. So weighted belongs to a type of sentiment analysis that is based on lexicons of sentiment related words. In this approach, each of the words in the lexicon is rated as to whether if it is positive, negative, and in many cases, it will also tell how positive and how negative a word is or a sentence is. And below, as we can see, this is the weighted sentiment analysis part. And over here, what I've really done is I've done the word tokenization in order to find the top negative, neutral, or positive words. Same thing is done on sentence as well. So let us first see how the word sentiment analysis looks like. So over here we have imported sentiment intensity analyzer. So this is the Vader sentiment. This will tell us if a particular word is positive or negative in nature. And we have given a polarity score over here. So what we have done in this piece of code is that we have created three lists, empty lists over here. One is the positive word list, the other is the negative word list, and then we have also have the neutral word list over here. And we have given a for loop over here, which mentions that if a word has a compound score greater than or equal to 0.1, then such word gets appended in this positive word list. And if a word has a compound score which is less than equal to minus 0.1, then such words will get appended in the negative word list, and the remaining leftover words and the leftover compound scores will be appended in the neutral word list over here. Okay, and these are the print statements over here, and this statement over here will show all the top 100 positive and 100 negative words. So I've printed it this way. So these are the top positive words. These are the top 100 positive words. So you can see that trust, security, agreement, pretty, charm, all are positive in nature, wonderful, comforting. And but when it comes to negative words, we have printed the top 100 negative words. And as you can see, we have violence, timid, violence, prison, death, and we have like successfully created the top 100 positive words and top negative words over here. And the same thing has been done, but the previous sentiment analysis was based on a word. Now we do the same thing, but now we do it on a sentence. So now we have taken sentence, and as you can see, the same thing has been done over here, and we have the negative score, neutral score, and positive score, and then we also have the compound score over here. So we can again give a threshold value and classify a particular compound score for our sentence if it is positive, negative, or neutral in nature. And we have used the polarity score again, and over here we have created them into a data frame. So this is the text, and this is the negative score of that text, this is the neutral score of the text, and this is the positive score of the text, and then we have the compound score. So we can use this compound score again and give a threshold value and classify a particular text as positive, negative, or neutral. So but before we do that, we can also find out how positive, like we can also find out which sentence among all the 1,000 sentences are highly positive or highly negative or highly neutral in nature. So first thing that we have done is we have selected the most popular sentence using the compound score. So the highest compound score will show us how popular a particular sentence is, and we have arranged this compound score in a descending order. So we have just taken this compound score over here. As you can see, we have sort values, and we have done that by the compound column, and this is how our data frame now looks like. So over here we can see that this sentence over here, I firmly believe this is the highest compound score that a sentence has got. So let us go ahead and print that particular sentence, and this is that sentence. I firmly believe that the Oscar, this sentence has the highest compound score. And in order to find the top positive sentence, the same thing has been done, but instead of taking the compound score, we have taken the positive score over here. So we have arranged this particular column in a descending order, which is nothing but our positive column, and we have done that by using the sort values. And now that now you can see that the sentences have been arranged in descending order based on this positive score. And then over here we have this text over here, mystery man, which is 161. So this mystery man have got this sentence is the highest positive sentence in this particular data frame. Same thing has been done for the negative sentence. Now we have not taken the positive, but we have taken the negative values, and we have sorted them in the descending order. And these are our negative sentences over here. And over here, as you can see over rating this sentence has been printed, and let us check how if this sentence is really negative in nature. So this sentence says a rating of do not begin to express how dull, depressing, and relentlessly bad this movie is. So this sentence is really negative in nature, and yeah. So let us go ahead and give threshold values and classify a particular sentence as positive, negative, or neutral. So we have done the same thing over here, but here we have taken the sentence, and wherever the sentence has a compound score that is greater than equal to 0.5, then such sentences are getting classified as positive. And if a compound score is less than equal to 0, then such sentence will be classified as negative, and the remaining sentences over here will get classified as neutral. And these are our predicted values over here. These are our predicted values. And as you can see, every sentence has been classified as either negative, positive, or neutral. So next thing that we do is we have added this particular predictions as a target column. So all these predictions have been saved as a target column, and these are our predicted values now. And as you can see, these are the sentences, and these are the negative scores, neutral scores, and positive scores. These are the compound scores, and then in the end, after the calculation and using the threshold value, we have our negative or positive scores over here. And then the remaining columns like the neutral, negative, positive, and compound scores have been dropped, and then we are left with only the text column and the target column over here. And for now, we have completed the sentiment analysis. We first cleaned the data. We pre-processed all the data and removed the special characters. And then we used the sentiment analysis, the weighted sentiment analysis, and we gave a compound score. And using a threshold value, we have separated a particular text as if it is negative, positive, or neutral in nature. And let us see here how many positive values and negative values are in our data. So we have used the value underscore counts over here, and this shows us that there are total 568 positive values, 316 are negative values, and 63 neutral values in our data. So the data was actually of 1000 rows. So we have two columns in our data set now. And before we apply machine learning model on this data, what we do is we'll have to label encode this target column, and we do that with the help of a label encoder. And what really a label encoder does is that it converts all the categorical values into numerical ones. And using the label encoder, we have given we have encoded our values now. As you can see, the positive value is now converted to 2, and negative is now represented with 0, and neutral is represented by 1 now. And this is our label encoded data set. And after that, we have done the TF-IDF vectorizer. There is another vectorizer called as count vectorizer. It can be used as well, and we can compare the accuracies of the TF-IDF vectorizer as well as the count vectorizer. For now, we have used the TF-IDF, and what the TF-IDF vectorizer does is that it transforms text to to feature vectors, which can be used as an input to estimator. So we have done that using the TF-IDF vectorizer. And after vectorizing the text column over here, we have split our data. We have used around 80% of the data for training purpose, and 20% of the data is used for test purpose. And over here we have given a random state which is 40. So what this really does is that, let's say two people use the same random state, then they both are likely to get the same results. And after that, you can see this is our X train shape, X test shape, Y train shape, and Y test shape. And over here, we have used a logistic regression model. And as you can see, we have fit the model on X train and Y train. And then we have predicted our logistic regression on the X train. And this print statement over here will show the model accuracy, and this will show the model accuracy on train, and this will show the this print statement will show the model accuracy on test. And as you can see over here, our model accuracy on train is 91 and the model accuracy on test is 65. Apart from logistic regression, we can also use other machine learning models like the decision tree classifier, and we can also use the random forest classifier. We can also use the support vector machines, and in the end, we can compare all these models with their evaluation metric, which is the accuracy, and come to a conclusion which model performs well. And over here, as you can see, the logistic regression has given us an accuracy that is 65%. And let us go ahead and compare the other machine learning models accuracy. And over here, you can see these are my imports. And in the imports, I've imported the decision tree classifier. And then we have the random forest classifier. We also use the k-nearest classifier over here. This is the KNN model. It is called as k-nearest neighbors. And this is the support vector machine. And when it comes to decision tree classifier, what a decision tree classifier does is that it breaks down a data set into smaller and smaller subsets. And decision trees are known to be good for both classification and regression problems. And when it comes to a random forest classifier, random forest classifier is a machine learning algorithm which can again do the same task as decision tree. It can work very well for regression and classification use cases. And random forest classifier is actually called as an ensemble method. And random forest model is actually made up of large number of small decision trees. So it's a collection of small decision trees. And then we have the k-nearest classifier, and this is called as the k-nearest neighbors. And then we have used the support vector machine. Support vector machine is called as a supervised machine learning algorithm. Again, this model can be used for both classification and regression problems. And all these models are going to get evaluated with the help of metrics. And the metrics that we are going to use over here is the accuracy score and the confusion matrix. And what a confusion matrix really does is that it will tell us how many predictions were classified correctly and how many predictions were classified incorrectly. So it is good for classification problems. And over here, as you can see, this is my decision tree classifier. And what we have done here is that we have fitted the model, and we have over here this line of code. It says that we have predicted the decision tree on the X train, and we have printed over here we printed the model accuracy on X train, and over here we have predicted the decision tree on X test, and then we have predicted the models on the X test as well, and we have printed it over here using the print command. And over here you can see we have given this code. What it really does is that it will draw a line, a dotted line, which will repeat for 50 times. And then over here we used a confusion matrix, and this confusion matrix will tell us how well our model is classifying. And over here we have made the calculation of this confusion matrix, so it will predict how many predictions were wrongly made. And then we also use the kappa score over here. And as you can see over here, our model accuracy on train is 100%, and the same thing is on the test as well. So what this really shows us is that our model is overfitting, and this has to be tackled. And as you can see over here, the wrong predictions out of total are 0. This is a overfitting model. So let us go ahead with another model, which is our random forest classifier. And as you can see, same thing has been repeated over here, but the model that we used here is the random forest classifier. We have fitted the model on X train and Y train, and then we have predicted on the X train, and here here comes a print command, and the same thing has been done on the X test. We have used the random forest model to predict on the X test and print the same thing over here. We are predicting the accuracy on X test, and again this line of code will draw 50 dotted lines. And over here we are using our confusion matrix, and the confusion matrix, so the calculations of the confusion matrix are done from this code. And as you can see over here the model accuracy on train is 100 and our model accuracy on test is 60. And over here we have used the confusion matrix, and this is the total number of wrong predictions made by the random forest classifier. And as you can see over here, the total number of wrong predictions made are 80 by 200. So this is not a very bad model. It can be further improved. And then we have used the k nearest neighbors. But so far, we have a good model over here. The random forest classifier has performed very well compared to the other models. And the logistic regression also has given us a 65% accuracy. And over here, we come to a conclusion with the k nearest neighbors. So we have used the k nearest neighbors and fitted the model on X train and Y train. And then we have predicted on the X train, and this is our model accuracy. We have printed the X train prediction, and over here we have fitted we have the predict on the X test, and this is the model accuracy on test. And then again we have the 50 dotted line, and over here we have printed a confusion matrix, and these are the total calculations made by the confusion matrix. Over here we have done the calculation part, and as you can see over here, the model has given us an accuracy of 71% on train, and the model's accuracy on test is 55. And this is our confusion matrix over here, and the total wrong predictions made out of total are 90 by 200. So so far our random forest classifier and logistic regression have performed very well compared to other models. The other thing that can be tried here is that we have used a TF-IDF vectorizer. The same can be done using the conv vectorizer, and we can apply the same machine learning models on the conv vectorizer to see if there is any increase in accuracy on these models. And apart from all these models, I've also used another model called as support vector machine, and let us see how the support vector machine works. And as you can see over here, this is our support vector machine, and I used a kernel which is linear, and then I fitted the model using svm.fit on X train and Y train. And over here we are predicting on X train, and this line over here will predict the model accuracy on train. Over here we have predicted the support vector machine on X test, and again this will print the model accuracy on X test. And then this is the confusion matrix which will be used for evaluation. And again this is our total number of wrong predictions made. We are calculating this from the confusion matrix, and as you can see over here, this model also has performed very well. The model accuracy on train over here is 94, and the model accuracy on test is 69. And over here you can see this is our confusion matrix, and these are the total number of wrong predictions made. And over here we have 61 wrong predictions out of 200, which shows that support vector machines has worked very well, and the decision tree classifier has overfit. And in the end we can conclude that support vector machine is the better model for our sentiment analysis use case. This model can be further improved, and the accuracy can also be improved. We can try using the conv vectorizer as I told earlier. But for now, this is it for this video. We can also use XGBoost classifier to see if there is any improvement in our model. We can also use conv vectorizer and run all the models again to see how well the model performs and check if there is any difference in the performance of these machine learning models. And we can also use other machine learning models and compare every model to see how these models work. But so far the support vector machines has given us a good accuracy. with the total number of wrong predictions are 61. And that's it for this video. And thank you for watching this video. Have a good day and take care.